All right, hello everyone. This is Maria Aguape from SK Ghost Associates, and I would like to welcome all of you to our today's webinar on Chapter 9, Fire Protection and Life Safety Systems. Our speaker today is Mr. Kevin Scott. While he's presenting, please type in your questions anytime in the chat box at the bottom of the Zoom screen, and the questions will be addressed by Kevin at the end of his presentation. The chat box will serve as our Q&A box, and only Kevin and I will see the questions submitted in there. Also, you should have received a PDF handout of the seminar material that Kevin is going to show during his presentation. Having a printed copy of that will facilitate your notes taking during the webinar. With that, Mr. Kevin Scott, ladies and gentlemen.
Thank you, Maria, and good morning, everyone. Welcome back. We are talking about Chapter 9, which covers fire protection systems and life safety systems in the building code. So if ready or not, here we go. We're just going to start off with some general concepts initially that are critical. Before final, all fire protection systems, life safety systems have to be inspected and tested. The testing requirements and many of the inspection requirements are typically contained in the reference standards. For the sprinkler system, we go to NFPA 13. For the fire pump, we go to NFPA 20. For the fire alarm system, NFPA 72. So typically those testing criteria are in the reference standards where the code designates where the systems are required. The standards tell us how to install them, how to test them, how to maintain them. One of the things that's new in the 2020 code is a reference to integrated fire protection system testing. And this is becoming more and more common where we have multiple fire protection systems, integrated fire protection systems, where you have, in this example, a fire alarm system that also will close doors, will activate smoke control systems, will provide even elevator recall. The simplest of this, a typical sprinkler system is in fact an integrated system where I have a sprinkler system and I have monitoring for that sprinkler system. The monitoring is a dedicated service or dedicated function fire alarm system. And my sprinkler system, they are interconnected and they need to work together. That's a very simple example. And in the simple example, it's not a big issue. Those can be tested typically. But when I get multiple systems within a building, and one depends on the other, and when this system activates, this is supposed to occur. But when this activates, a different response occurs. There's a new NFPA standard, NFPA 4, that is designed to provide for testing of these integrated systems. And in a high-rise building or a building with smoke control and a fire alarm, the code says use NFPA 4. And essentially what you end up with is a special inspection of the systems, making sure that when this domino falls, the correct next domino falls also. And that in a multi-story building with multiple systems, this could be a multi-day process because you're dealing with multiple contractors typically. Fire alarm, sprinkler, elevator control, HVAC, door hardware. You've got multiple contractors, and typically when these inspections are done, when that a specific contractor isn't there, it's typically everyone's going to point a finger at it didn't work. He's here. Too bad he's not here. We could have fixed it. So this basically says get a special inspector to come out and do this. You get a report. It's intended to make the inspection process much easier. And once I have the system approved at the time of C of O, it says I need to retest it under this NFPA 4 every 10 years. One exception to that, if I have smoke control, The smoke control portion is tested every 6 months. The smoke control is required to be tested every 6 months. And there's two terms when we're talking about fire protection systems and life safety systems. There's two terms that are critical to understand because many of the requirements are based on how we apply these terms. The level of exit discharge and fire area. So the level of exit discharge is the story. It's not the floor. It is the story, the entire, sorry, when I say the floor, I mean the walking surface. It's not the walking surface. It is the entire story. It's the story at which exit terminates and exit discharge begins. It's the story where you leave the building. That is my level of exit discharge. My level of exit discharge. And a building can have more than one level of exit discharge. I've got a building, and it's going to have, in this case, I've got two levels of exit discharge. I've got the highest level of exit discharge and the lowest level of exit discharge. This may be a 3-story building. It may be a 2-story building with a basement. It doesn't matter because the requirement for many things is going to be, for example, group A occupancies are required to be sprinklered when they are not located on a level of exit discharge. So I have a group A on the first floor. It's on a level of exit discharge. Requirement doesn't apply. It's on the second floor. It's also on a level of exit discharge. Requirement doesn't apply. It's on the third floor. Now I have to sprinkler the group A occupancy. So I can have multiple levels of exit discharge. The other requirement is for fire area. And the fire area definition says it is the aggregate floor area enclosed or bounded by, so it's surrounded by firewalls, fire barriers, exterior walls, which may or may not be fire rated, and horizontal assemblies, which in our discussion last week, horizontal assembly, remember, is a fire rated assembly, fire rated floor ceiling assembly. Areas of the building that are not provided with surrounding walls, the porte cochere in this photo here, are included in the fire area if they're within the horizontal protection or a floor above. So we would include that area when we're looking at fire area. Fire area is not necessarily equivalent to floor area. Two different terms, both defined separately and both used in different applications. The time when we're looking at fire area, we're looking at what's the size of the fire area that is going to require sprinklers, or what's the size of the fire area to determine fire flow, or what's the size of the fire area for, what's the occupant load within a given fire area for fire alarm systems. Two different terms. So there's different ways that the fire area could be applied. First rule, every building is at least one fire area, bounded by exterior walls, rated or not. It's bounded by exterior walls. So every building is at least one fire area. Can I have more fire areas? I separate it by fire barriers, and now I've created 3 fire areas. They could all be the same occupancy classification. I just have 3 separate fire compartments, essentially, in this building. The number of fire areas is unlimited. However, in certain occupancies, and we'll look at those when I get above an aggregate area, the requirements apply regardless. My fire areas could run multi-story. I have 3 fire areas in this building. As long as it is a continuous fire barrier or firewall that runs from foundation to roof, I've created 3 fire areas. Each fire area consists of 3 stories. I put in horizontal assemblies. I've again created 3 fire areas. So it's the areas of a building separated by fire resistance rated construction, bounded by exterior walls in a building. Each one is a separate fire compartment, completely separate. Here's an example of a 2-story building here. I have separated the Group A2 occupancy from the remainder of the building, the Group B, by fire rated construction. So now the question is, how many fire areas are there? There are 2 fire areas. Since my horizontal assembly terminates here rather than the entire floor, I've got an fire area here and a fire area here. The fire area 1, 25,000 square feet. Fire area 2, 7,000 square feet. And then when we're looking at applying this, we look at what's the square footage in each fire area, what's the occupant load in each fire area, is the fire area on a floor other than the level of exit discharge. Well, we've talked about separating fire areas. The question is now, what is the fire rating that's required? We looked at this table also last week. Chapter 7. The requirement to separate fire areas, horizontal assemblies, fire barriers, firewalls, between fire areas. Not between occupancies, between fire areas. So I have a Group B. I've got Group B on each side. I'm just creating a fire area. I need a 2-hour separation. I've got S1, warehouse, 3 hours separation. In order to anything less than that, we would not consider it a fire area. It may be separated for some other reason. We may have a fire resistant rated wall for some other reason, but it does not create a fire area. The definition of fire area says it's fire resistance rated construction, which leads you to believe, oh, it could be 1 hour. But based on this table, 1 hour only applies to Group U. And I've never seen it used in a Group U. Fire pump and fire riser room. The fire pump room or fire riser room is not required. But if one is provided, there are specific requirements they have to comply with. Number 1, it has to be large enough so that I can get anything in there, any piece of equipment out without having to disassemble anything. The same requirement applies to my fire pump room, my fire sprinkler riser room. So I have my fire pump inside that room. And it's a diesel driven fire pump with a diesel engine. I need a big enough opening so I can remove and replace that diesel engine without having to spend a day disassembling it to get it through the door. I disconnect it, bring it out through the door, bring a new one in, connect it. The intent of all that is to provide room for working so people don't get hurt. But beyond that, to reduce the downtime, the time that the system's out of service. So in my fire pump, my fire riser room, I have to provide access. It has to have access either directly from the exterior or from a fire resistance rated corridor leading to that room. It has to be identified. I have to maintain the temperature in there at least 40 degrees or higher. Fire sprinkler riser room, I've got water in there. Fire pump room, I've got water in there. We have to maintain it at 40 degrees or higher. Why 40 degrees? Water doesn't freeze at 40 degrees, it freezes at 32. But at 40 degrees, it starts to make that little slush, the icy. It starts to form water crystals. So we keep it at 40 degrees or higher to prevent that from happening. I have to have lighting in that room, normal lighting, and in my fire pump room. not the fire rise room, but the fire pump room. I have to have emergency egress lighting. So I have to have secondary power for some of the lighting systems in my fire pump room. That requirement is an odd requirement. It's found in Chapter 10 for emergency egress lighting. My fire pump. I'm going to install a fire pump. There's my fire pump. The fire pump, the installation has to comply with NFPA 20. So we go to NFPA 20 for the installation design. But now I have my fire pump room. We said we designed the fire pump room. We've got plenty of access around the pump. And where do we get that access, the distance, the spacing? Where do we get that dimension? For any electrical panels, there's a minimum requirement of 30 inches in front of any panels. And that would include my fire pump control panel, my fire alarm panel, my smoke control panel, any of those systems, there's a minimum working space of 30 inches in front. Around the fire pump, you're going to get that from the manufacturer's installation instructions. But my fire pump room, the room now, I provided the room, and that room is a 2-hour construction, 2-hour separation between the rest of the building for my fire pump room, if it's a high rise. If it's not a high rise, it's a 1-hour separation. Or another option, don't put it in the building, separate it from the building. It's a detached fire pump room. Then and it's detached by 50 feet, no fire resistance rating required. Do I even need a fire pump room if I detach it from the building, since no fire rating is required? The code and NFPA 20 never come out and say you need a fire pump room. However, they both say you have to protect the fire pump from vandalism, rodents, weather, all this whole list of items that I don't know how you do it without a fire pump room. The fire pump room is not specifically required, but I don't know how you meet the code and the standard without providing one. This is a diesel fire pump in the photo, but if it was electric, I'm bringing power into that fire pump room. The power to the fire pump, to the panel, has to have 1-hour protection. There is cabling that it provides 1 hour. In fact, you can even get it up to 2-hour rated cabling. It is I've got an insulation, ceramic type insulation, my conductors here. It's got a copper sheath on the exterior, like a thin copper tubing. So it doesn't bend easily. The installation of this, if they're using this, the installation of this material does not have to be protected with 1-hour construction. It can be exposed. But there are specific installation requirements that you're going to find from the manufacturer or from the UL listing that they have to comply with when it's installed. Once the cables get inside my protected fire pump room, I no longer have to provide the 1-hour rating on the cabling. But it's when it passes through the remainder of the building that I need to protect it. Or I place it underground. That's also considered equivalent. In my fire pump room, I have let's go back here a second. There's my fuel tank. There's my fuel tank. Okay. How much fuel can I put in there? The code says if it's class 2 or class 3 combustible liquid, which if it's gasoline, it's class 1. We don't find gasoline-driven fire pumps. If it's diesel, it's class 2. If it's biodiesel, it's class 3. Or fuel oil is class 3. Says if I'm using class 2 or 3, which is going to be the typical application, I don't even include the quantity when I'm looking at the maximum allowable quantity for hazardous materials within the building. In other words, with class 2, with a limit of 330 gallons, it could be doubled if the building's sprinklered, which typically they will be, to 660 gallons. I can go to 660 gallons. I can go beyond that, and I'm not going to count the quantity when I'm looking at the maximum allowable quantity in the building. I can double it to 1,320 gallons if the building's sprinkled. I can almost up it 5 times to 3,000 gallons if this is a protected above ground storage tank, which this one is. The protected above ground storage tank is listed to UL 2085, and it's designed to survive a 2-hour fire exposure. Fire directly underneath it, it survives a 2-hour fire without losing contents, without disforming or distortion, and it survives that fire. So I can go to 3,000 gallons. My allowable quantity under the maximum allowable quantity table was 330 or 660 if it's sprinklered. I just put 3,000 gallons in there for the operation of the building. I'm using this as part of the operation, or basically it's my utility fuel for the fire pump. I don't have to count it. In a high-rise building, code says I have to have a fuel supply to last 8 hours. The 3,000 gallons is not unheard of. I have to run in a high rise. I've got a generator that's going to run my fire pump, my smoke control system, my fire service access elevators. I need a lot of fuel for an 8-hour operation because this applies to fire pumps and generators if the generator is supplying the fire pump. So 8-hour supply, and we don't count it. So now let's look at sprinkler systems. Where are sprinkler systems required? And there are 3 standards that the building code and fire code recognize for sprinkler installation. NFPA 13, which covers every building. NFPA 13R, which is limited to low-rise residential, maximum 4 stories, maximum 60 feet in height, R1, R2 occupancy, or R4. 13D, D is for dwelling. This is a 1 and 2 family dwelling or manufactured home. NFPA 13, I can sprinkler all of these occupancies with this system. However, I end up with sprinklers in more locations. It becomes more expensive. There's one other option. The residential code, section 3R313, has design criteria for sprinklers in the dwelling, 1 and 2 family dwelling. So I can use, as a designer, I can use any one of those systems to design my sprinkler system if the building I'm protecting fits with the description. It's a 3-story hotel. I could use 13R. I could also use NFPA 13. And why is this important? Because there are some allowances in the code that only apply in that R occupancy if I use NFPA 13. Dead-end corridors is one of them. Dead-end corridor in a hotel is limited to 20 feet if I use NFPA 13R. However, I can go to 50 feet if it's NFPA 13 sprinkler system design. Why is that? They're both sprinklered because this design of the sprinkler system is different. When I'm using NFPA 13, I'm protecting the whole building. I've got sprinklers throughout the building, in the attic, in small offices, in small spaces, in concealed spaces often. When I'm using 13R, basically I'm protecting the occupied spaces. No sprinklers in the small closets, small bathrooms. 13D, I have even other locations where sprinklers aren't required. And why is this? Because the intent is different. NFPA 13 is designed, its main focus is to protect the building and the contents. Secondary protects life. The NFPA 13R and 13D and the residential code, they are designed for life safety. Their goal is to limit the size of the fire to provide time for people to exit. The advantage, yeah, they also provide property protection, but that's not their main function. That's not their purpose. But that as a added benefit, you get that ability. And we talked about the limitation on the various standards, the various designs. NFPA 13, I can sprinkler anything. The other two, I am limited to the application. Design methods, well, basically NFPA 13, and anytime a sprinkler system is designed, it's designed to handle one fire at a time. One fire at a time. So, and when I'm looking at NFPA 13, we're going to assume the minimum size of the fire is 1,500 square feet. Protect for that. NFPA 13R, we're going to assume the fire occurs in one room. Protect that room. Give the occupants time to leave. 4 sprinklers. I only use 4 sprinklers. NFPA 13, I could have up to 20 fire sprinklers operating at once. 13D, 2 sprinklers. And that's only if there's 2 sprinklers in one room. If every room in my dwelling has only 1 sprinkler, only 1 sprinkler has to operate. How long do they operate? 13 up to 2 hours, because we're protecting the building. We're protecting for the duration of the fire. 13R, 30 minutes. The time to evacuate, essentially. 4 stories, maximum 60 feet, 30 minutes. 13D, 7 to 10 minutes, depending on the size. 1 story under 2,000 square feet, 7-minute duration. If it's 2-story or over the square footage, I need 10 minutes. Time to get people out. So the systems are different. The allowances or modifications in the code is different based on the system you provide. Many times it's the same, but there are differences. But here's the key point. Because the code will say, we already talked about maximum allowable quantity. I can increase my maximum allowable quantity. I can double it if the building is sprinklered throughout. I can increase my travel distance or increase my dead end corridor length, both of them, if the building's sprinklered throughout with 13R or 13. Well, wait, we don't put sprinklers in all the places here. This is the key point. When the code says sprinklered throughout, it means you put sprinklers where they are required. You didn't sprinkler the attic space, but you put sprinklers where they are required with 13R. That is considered sprinklered throughout. And the code uses that term off either sprinklered throughout, installed throughout, equipped throughout the building. As long as you comply with what the code says and what the standard says, you have provided sprinklers throughout. So where are sprinklers required? Based on occupancy classification. Sprinklers in Group A. Whenever I have a Group A that is not on a level of exit discharge, the entire story has to be sprinklered. Even if the Group A does not occupy the entire story, I have to sprinkler the entire story. And sprinkler all stories down to all levels of exit discharge. So in this case, I've got a story above that's not sprinklered and floors below that aren't sprinklered. There may be other criteria that's going to tell me, hey, I got to sprinkler these, I got to sprinkler this also. But based on the requirement, based on occupancy, that's all I have to sprinkler. That building is not, if that's why I only put sprinklers in those locations on those floors, that building is not sprinkled throughout because I didn't meet the sprinkler requirements. A1, when would you run into this? Existing building. I've got an existing building that's not sprinklered. They want to add a restaurant on the top floor. And it's got a basement. Technically, they don't have to sprinkler the basement. However, when they do that, the building's not sprinklered. So increased travel distance from the A occupancy, they don't get to take advantage of that. Elimination of rated corridors for the A occupancy, they don't get to take advantage of that because the building is not sprinklered. So A1 occupancy. When my fire area, here's our fire area again, bounded by fire rated construction or exterior walls. Fire area exceeds 12,000 square feet, it requires sprinklers. When the fire area has an occupant load of 300 or more, it's required to be sprinkled. Fire area is not on the level of exit discharge, or the fire area is a multi-theater complex. And if any of these thresholds are crossed, I have to sprinkler the entire floor and all floors to the level of exit discharge. A2, restaurant, casino, drinking, dining facilities. Fire area has reduced. We got a higher life hazard, 5,000 square feet or an occupant load of 100 or more. New requirement here. Building is more than 5,000 square feet. It's exceeded that. But I'm going to create fire areas. Oh, so it's got more than one fire area. But the fire area now, in order to consider it to qualify for this 5,000, it has to have a 4-hour rating. So if it's got more than one fire area and the fire area is less than 4 hours separation, or the fire wall has openings in it, we don't consider that a separation when determining fire area. So we would ignore that wall, and if we exceed 5,000 square feet, it would have to be sprinkled throughout the floor and floor levels to the level of exit discharge. A3, A4, fire area of greater than 12,000 square feet, more than 300 occupants, level of exit discharge it's not on the level of exit discharge. Same criteria, however, this only applies to A3. More than 10,000 square feet, firewall is not 4-hour or it has openings in it, it has to be sprinkled. A5, outdoor structures, not limited to grandstands, bleachers, but they certainly fit in that group. Any enclosed rooms or areas accessory to the A5. In this case, I've got either a control room or a announcement room. Has to be sprinkled. Has to be sprinkled if it's over 1,000 square feet. If it's beneath the seating, I have an option. Up to 1,000 square feet, I have to have a 1-hour separation between the fire load and the occupants. If it's over 1,000 square feet, I need to sprinkler it. If it's under 1,000 square feet, I could sprinkler it, or I could have a 1-hour separation. I want to put an occupancy on the roof. If this occupancy the assembly occupancy or the assembly use, it's not really an occupancy, it's a use. So we'll call it an A. They're going to be eating, they're going to be drinking, they're going to be whatever they're doing up there. If it was on this floor, we'd say sprinkler the floor and all floors below to the level of exit discharge. It's not on the floor, so we can't sprinkler the roof level. But we do sprinkler everything below that. The threshold for an A2, drinking, dining, more than 100 on the roof. Every other A use, every other assembly use, more than 300 on the roof. You'll run into this also on existing buildings where I want to modify my existing building to use that roof area. This requirement does not apply to open parking garages. So I've got my A occupancy on the roof of an open parking garage, or the top tier of an open parking garage, if it's of type 1 or type 2 construction. There is an allowance, and this basically only applies to group A occupancies when we're looking at the occupant load. I've got multiple group A occupancies in this building. I've got a restaurant, art gallery. All three group A have also got group M. But when they're in the same building, I've got multiple fire areas. I separate them all with fire barriers. Each one is a separate fire area, but now I have multiple group A fire areas in the building, and they share egress. They share, that's the key. They share egress, and the combined occupant load of the group A only is 300 or more. I've got 93, 123. I've got 306, 309, 309. I'm over 300. Then I have to sprinkler the entire floor, which now includes the group A, or I'm sorry, group M. I have to sprinkler the entire floor, and then all floors to the level of exit discharge, if that would be applicable. But as soon as I put sprinklers in, I no longer need to create fire areas. These 2-hour walls can go away unless I'm using it to separate occupancies for a different reason. But I no longer need them to create fire areas. Here's my same occupancies, my same building, and I've separated, or have I separated? Have I separated the A occupancies? I've got 4 tenant spaces, but only 2 fire barriers. This fire area has an A occupancy, and we would evaluate this A occupancy on its own. It's under 100, it's under 5,000 square feet, sprinkler's not required. This is an A3. Here's my fire area. Exterior wall, 2-hour wall, exterior wall, 2-hour wall. It's an A3. It does not exceed, at an A3, occupant load of 300 or fire area of 12,000 square feet. Sprinkler's not required. Here's my third fire area. My fire area can have more than one occupancy classification. This one's separate from these. We're good. We're good. Sprinklers not required because in this case, they do not share egress path. Group B, as a general requirement for Group B, there is no sprinkler requirement unless it is an ambulatory care facility. Ambulatory care. I come in the morning, I have my surgery, I leave. There's no overnight stay. No, not longer than 24 hours. Sprinklers required, though, if I have more than 4 care recipients incapable of self-preservation. I walked in the morning, I can get out, except for the time that I'm sedated or in the middle of surgery. So I'm incapable of self-preservation, either because of the way I came in or I'm put that way during the time that I'm there. More than or four or more. So how do we determine 4 or more? I've only got one operating room. That doesn't mean just one. Care recipient incapable of self-preservation. You've got to look at the whole scenario, because I come in, I'm in pre-op. They're starting to put me under. I'm in the surgery. I'm in post-op. I'm in recovery. Am I fully cognizant in any of those locations? Probably not. I'm going to argue that even that you're going to be at some level, altered level of consciousness during those situations. So I have 4 locations: pre-op, surgery, post-op, recovery. I would determine this based on how OSHPD determines occupants in a hospital. How many beds do they have? How many beds do they have? That's how they determine that. Sprinklers in this facility need to be quick response or residential sprinklers. That only means that they're going to operate faster when the fire is smaller, because now we have people that cannot escape on their own. Group E occupancy, educational. And we're really lucky in California. We have all kinds of Group E occupancies. We have public schools, we have private schools, we have parochial schools, we have schools funded by the Leroy F. Green Act, we have charter schools, we have all kinds of schools, and we have new public school campuses. And each one has a different set of requirements. Group E, the requirements for Group E, you are going to apply to private schools and daycare. The public school campuses, the Division of State Architect, DSA, is going to do that review. You probably aren't even going to need to worry about that. So in my Group E, fire area greater than 12,000 square feet, or it's below the level of exit discharge. I've got a basement. I've got a lab or vocational shop with hazardous materials less than the allowable quantity. Less than. I've got a lab or vocational shop. I've got a building that's more than 12,000 square feet with more than one fire area, but the fire area is not a 4-hour wall, 4-hour firewall with no openings. You can sprinkler probably most of them, if not all of them. New public school campuses, you sprinkler all of them, every single one. F1, factory. We're back to our 12,000 square foot fire area. However, this one's a little different. Now, if I have a fire area that's more than 3 stories above grade, so my fire area, I've got just one fire area per floor, and it's 10,000 square feet per floor. I've got 4 stories. I've got a fire area that's more than 3 stories above grade. One of the changes in Group F, and we'll also see in Group M and S, is I have more than one fire area. Even only separated with F1 is a 3-hour separation. But I'm going to add them together. And as soon as I exceed 24,000 square feet, even with my proper separation, it has to be sprinklered. It has to be sprinklered. I'm manufacturing upholstered furniture or mattresses, 2,500 square feet. I've got a higher hazard, 2,500 square feet. Also, woodworking operations are at 2,500 square feet. Same allowance here. I'm gonna separate into fire areas below 2,500. There has to be a 4-hour firewall with no openings. Group H occupancies. Fire sprinklers required in all Group H. And there's times now when the code has requirements, specific requirements for sprinkler design. There are times in the code where the code says, oh, you know what? Go to NFPA 13, which would be appropriate for Group H, but the minimum design is ordinary hazard Group 2 with a fire area or an operating area of 3,000 square feet. That means all the sprinklers within 3,000 square feet can operate at the same time. Let me make sure that's clear. Because contrary to all of the Tom Cruise movies, when sprinklers in a building operate, that sprinkler operates. It reacts to heat, the component melts, the sprinkler discharges water. That sprinkler discharges water, not the entire floor, not the entire building. In a building occupancy, a typical building occupancy, each sprinkler operates independently. Each sprinkler operates independently. They're not designed to all go off at once. There are times when that is an appropriate design, like in an aircraft hangar. They all go off at once. They all go off at once. But that's a specific application. But even though the code says I've got to comply with this, now the thing is, the code says this, the standard NFPA 13 says, oh, I could do light hazard because my hazardous materials are not combustible. They don't burn. They're toxic. That's how I got the H classification. They're toxic. Can you hear me now?
Yes.
Okay. They're toxic, but they don't burn. The whole concept with this is, yeah, but something else in that building does burn. We're going to keep it from getting to the hazardous materials. That's why we have this minimum sprinkler design. But there's many times where that sprinkler design is inadequate. Flammable liquids, flammable gases, oxidizers. There's all kinds of hazardous materials that this sprinkler design, even though it's much greater than a typical building design, would not be adequate. That's part of the sprinkler design in the system. Yep. These quite often are going to result in, I need a fire pump. Group I, all Group I buildings are sprinklered. The requirement for Group I is sprinkler the whole building. So if I have a Group I fire area in a building, and there's Group B, and there's Group M, and there's Group whatever, I sprinkler the whole building because of the Group I occupancy. And again, anytime we're sleeping areas or areas where people cannot escape on their own, they're incapable of self-preservation, we use quick response sprinklers or residential sprinklers. Group L, laboratory. Sprinkler the whole building. Sprinkler the whole building. Again, we have a minimum sprinkler design. We don't have the same level of sprinkler design as we do for Group H because the quantities of hazardous materials are far reduced from what they could be in a Group H occupancy. But the code still specifies the minimum sprinkler system design. So we have to comply with the code and the sprinkler design standard. Group M, mercantile. We're back to our 12,000 square feet, more than 3 stories, aggregate, more than 24,000 square feet. If I'm constructing multiple fire areas to stay below the 12,000 square feet, those fire areas have to be 4-hour walls with no openings. A group M occupancy, that makes it kind of tough. Or if I have it's used for display and sale of upholstered furniture and mattresses, and it's over 5,000 square feet. Group R, sprinkler R, all buildings that contain group R. Now, and group R is where we're going to find out, I can use NFPA 13 or 13R or 13D, but there are some limitations. I can use 13D dwelling if it's an actual R3, 1 and 2 family dwelling townhouse. Got it. But many times we build buildings like a group R4, and the code says comply with R3 requirements. Oh, wait, 13D. No, it's an R4. The code says you have to put an NFPA 13R sprinkler system in R4. So there are some limitations to how I apply that. The code has some limitations with regard to those. If the code says I can use 13D, we can use the residential code requirements in section R313. The requirements are also found in NFPA 13D. They're actually more restrictive. It's one of the more restrictive ways to design a sprinkler system in a dwelling. And then we have pedestal construction, where I have my fire separation, my horizontal assembly separating the fire separation, and I have an R occupancy above it. So what this question, or what these couple slides are going to address, is can I use NFPA 13R in the residential portion? Can I use that in my building? So when we're making that determination, because 13R is limited to 4 stories and a maximum of 60 feet. 4 stories. 1, 2, 3, 4, 5. Oh. Well, but wait a minute. What does the code say? So in my pedestal construction, I've got any occupancy other than Group H, and it is type 1A construction. That's required with a 3-hour horizontal assembly. Basically, we're creating 2 separate buildings. Just happens to be that one's on top of the other. When I'm looking at the number of stories, we're limited to 4. I count from the pedestal up. So I've got 4 stories. We're good. When I look at the height of the building, I'm going back to grade. What's the building height? 60 feet. We're good. So if we're no more than 4 stories, no more than 60 feet, I can use NFPA 13R sprinkler design in the residential portion, 13 below. But if I use 13R, not all of the sprinkler allowances are available to me as a designer. The dead end corridors are limited to 20 feet rather than 50. But with the 13R system, I end up with portions of that building that do not require sprinklers. And the sprinkler system design, the magnitude of fire it's designed to handle is reduced, because it's just designed to allow time for people to escape. If I exceed that, you have to use NFPA 13. It can be all one sprinkler system, and the bottom portion is always going to be NFPA 13 sprinkler design. And it's the same sprinkler system that continues up. It's just where I put sprinklers, how many sprinklers, the size of the water piping to supply the sprinklers, that changes with NFPA 13R above. Group S1, storage, back to 12,000 square feet, more than 3 stories, more than an aggregate of 24,000 square feet. Or I have a storage of commercial trucks and buses. This would be a fleet facility. This is not just I've got a parking garage where anybody can come in, hey, and they park commercial trucks in there. It's specifically designed for that. Manufacturing of storage and upholstered furniture or mattresses over 2,500 square feet. S1 repair garage. Repair garage. Sprinkler required when the repair garage is 1 story and the fire area is greater than 12,000 square feet. It's 2 stories and the fire area is greater than 10,000 square feet. Repair garage is in a basement, or I'm repairing. I've got a repair facility for commercial trucks and buses over 5,000 square feet. One other item, an odd one that we run into, I've got sprinklers required when a fire area storing tires could be new or used or waste. Fire area is greater than 20,000 cubic feet. So now we're looking at the floor area and the height. What's the height of the storage? Cubic feet. Enclosed parking garages. Enclosed parking garages when the fire area exceeds 12,000 square feet required to be sprinkled, or the parking garage is below another occupancy. Got to be sprinkled. I've got a basement or story with no openings. And we typically have applied this to basements. Everyone gets it, hey, yeah, it's a basement. How many openings do I have? But it also applies to stories above grade. I have to have openings, basically firefighter access openings on at least 1 wall. If I don't, I have to sprinkle it. Let's look at an example here. It says I have to have openings, and the openings have to be a minimum of 20 square feet. A single door, 3 feet wide. A single door is going to give you 20 square feet. Doesn't have to be a door, could be a window. And the code says I have to have an opening within every 50 feet. So I take my length of 170 divided by 50, I get 3.4. 3.4. Ooh, which way do I round that? Here's the question. If I provide an opening, 3 openings here, have I provided one within every 50 square feet or 50 lineal feet? I'm going to go to 120, 150. I've got 20 feet left over. I don't have one there. One way, when you ask yourself this question, when you're looking at which way to round in the code, if I provide 3, did I comply? If I provide 4, did I comply? It's only going to work one way. Sometimes it's a smaller number, depending if the requirement is minimum or maximum. So I provide my openings, and then the question is, what's the distance to the other side or the opposite wall? If it's more than 75 feet, I have to provide openings on the other side, or sprinkler the building. Buildings greater than 55 feet in height, sprinkler the building. Or I have a floor or a story, more 55 feet or more above the lowest level of fire department vehicle access. And it has an occupant load of 30 or more. The lowest level of fire department vehicle access is not grade. It's the street level, the street height. What's the lowest level of fire department vehicle access? And that would be the lowest street. My building takes up an entire block. Which street is the lowest elevation? That's where I start measuring from. This is not the measurement we use for high rise. When we're looking at a high rise at 75 feet, I'm measuring from the floor level for fire department access into the building. Floor level. It's a different way of measuring. This requirement for sprinklers does not apply to group F2 or parking garages, open parking garages. I've got a sound stage, new sound stage, regardless of size, has to be sprinklered. Code also specifies minimum extra hazard group 2 for the building. One requirement that is in the code and not in the standard, at least not in NFPA 13R. I've got a residential building. I'm going to sprinkle it with 13R. The code says if I have combustible construction or combustible siding, combustibles on the outside, on my deck, on my balcony, provide a sprinkler at that balcony. There have been numerous fires that are started by the barbecue that sits on the balcony, gets to the combustible siding, runs right up the building into the attic. 13R system, the attic is not sprinklered, and the building's gone. So the code says add a sprinkler here. 13R, because it's for life safety, does not require that. The code does. But when we go back to chapter 7 in the building code, it says, hey, but if you put this sprinkler here and your building is type 3 or type 4 construction, you can use type 5 construction for this balcony if that sprinkler's there. Oh, well, the sprinkler is going to be there if I have any type of combustible construction out here. So then this could all be type 5. One other exception to NFPA 13R. This only applies to NFPA 13R. So this also only applies to group R above, well, it doesn't even have to have a podium, but that was what it was intended for. 13R does not require sprinklers in the attic. But if my roof assembly, not building height, the roof assembly is more than 55 feet above the lowest level of fire department vehicle access, then I either sprinkler the attic, or I build it with non-combustible construction, or I build it with fire-resistant treated wood, or I fill the attic space, with non-combustible insulation, fill from roof joists to rafters, fill the attic. One difference here is how we determine that 55 feet. Because based on the building code, chapter 5, my height, that's my building height. We're not measuring building height. We're measuring the height of the roof assembly. We're measuring, basically, if I put a ladder along that on that roof, where would I hit the roof? That is my roof assembly height. If that exceeds 55 feet, then I have to protect the attic space. Other methods, other than sprinklers, what other extinguishing systems are there? And there's many that the code references: dry chemical, wet chemical, carbon dioxide, halon. There's many that are included in the code, each with a different purpose. Code will talk about a total flooding system. This is a foam system. Here's my hazardous material tanks, my secondary containment, and I'm putting in a AFFF, aqueous film forming foam solution here to handle any spill or fire within that location. But I protect the entire secondary containment. Here's a dip tank. This is a flammable liquid that they're collecting off these materials. They're draining here, dripping, we're collecting it. It's then refined and put back into the process. This drain board area has a carbon dioxide system that's going to discharge into this area. So many times these are specific application systems. And because they're specific application systems, there's two sections that govern their use. The automatic fire extinguishing system as an alternative to required sprinkler systems has to be approved. So in other words, there's a couple reasons for this approval. I'm going to use carbon dioxide. Okay, where are you going to use it? I'm going to use it in my office here. It's not appropriate for an occupied area. Carbon dioxide will put the fire out. It'll also kill me. So not an appropriate choice for that type of extinguishing system. So the extinguishing system has to be appropriate for the hazard. The second and probably more appropriate or important section says automatic fire extinguishing systems shall not be considered alternatives for the purposes of exceptions or reductions allowed for automatic sprinkler systems allowed by the code. In other words, where code says I can increase my travel distance if the building's sprinklered. Yeah, but I'm going to put this alternative in. Basically, what this section says is your building is not sprinklered throughout any longer. Then you don't get to take advantage of that. How do I do that? How do I install these systems in a building and still get that credit for the sprinkler system? I install the extinguishing system and sprinklers to protect that room. Because the problem with the the systems is they're one application and they're done. If it works, great. If it doesn't work, we got a problem. Like this dry chemical system inside this spray booth. If it works, great. But part of it working properly means that that door is closed. Could be held open with a magnet, closes during operation, during activation. That's okay, but the door is closed. Something like this happens, the system fails. Now I've got an uncontrolled fire. By the time it gets through the rest of the building where the sprinklers are, it's beyond the size of the fire that the sprinklers can handle. Dry chemical system is a good choice for flammable combustible liquids. Some ordinary or common combustible materials. It's a good choice. Carbon dioxide, it's effective, but it will also kill you. It works by displacing the oxygen in the air. Displacing the oxygen in the air. So when there's no oxygen, fire goes out. Halon, great system. It does not displace the air. It adds a chemical agent to the air that puts the fire out. You can survive I could put enough halon in my office here that a fire would go out and I could survive through that application. It would not harm me. One problem, Montreal Protocol, one problem with halon, it is an ozone depleter. No longer manufactured. What do we manufacture now? We have clean agent systems. Same concept. It's a gas, no residue left over. These things are great for computer rooms. Computer rooms. So here's my computer room, my clean agent system, or even my halon system. I have smoke or heat detection that's going to activate. That's going to detect a fire. One detector goes off, we get a signal, we get an alarm. Second detector goes off, we start discharging clean agent or halon through the piping system. There's my storage right there. That's my storage of gas, but that's a limited quantity versus sprinklers in that room where it's just going to continue to flow until we run out of water. I've got a control panel that handles the smoke detector or heat detector activation, sends a signal to discharge the agent into the building. And outside that building, I have an alarm. And just like other systems, things have to happen. Like this door has to close. System activates, this door closes to contain the gas that's delivered into the building, or into the room rather. One delivery application at the ceiling, one in the sub panel or the subfloor. One criteria for these systems is we're going to do a room integrity test. We're going to pressurize the room to see how much leakage there is. Because once I discharge the gas into this room, it has to stay in that room to be effective for at least 10 minutes. Is it going to? We're going to test the integrity of this room. Door has to close, gaskets around the door, maybe dampers have to close, ventilation system shuts off. Several things have to happen for that to occur properly. Water mist, new type of system, very effective for specific hazards, but, and it's water and it's kind of like a sprinkler system, but it is not equivalent to a sprinkler system, at least not yet in the code. It's not equivalent to a sprinkler system, but this is more, it actually discharges a very fine mist rather than larger drops, which you would typically get from a sprinkler system. And that mist cools things very quickly, absorbs heat, and extinguishes the fire. Here is my system, the equipment for my water mist system, but it's a limited application. To get these small water droplets, less than 1,000 microns, to get these small water droplets, what this means is the diameter of 99% of the water droplets is less than 1,000 microns. So it's small. It's a mist. It is a mist. To get that, I'm adding high pressure. These systems run 1,000 pounds, 1,000 psi in the system as it's discharging to get that fine mist. But again, limited application. It doesn't continue like a sprinkler system does. That's why they don't count as replacement or equivalent to sprinkler systems. Cooking appliances. Fires happen at cooking. They're cooking with fire, and they're handling combustible liquids. They're handling grease, oils, fats. We have a lot of fires, and the biggest issue is the grease is captured by the plenum, which it's supposed, by the exhaust hood, which it's supposed to happen, and then the grease and the air travels up through the exhaust duct to the exterior, but as it's traveling, it leaves behind a residue of grease on that ductwork. That residue is what the biggest hazard is. Because once I have a fire, and I'm going to have fire, I'm going to have flames, when it ignites and gets large enough and we get fire up into that ductwork, that grease will burn. The grease will burn. So we protect the cooking appliances. We're protecting all cooking surfaces. I've got nozzles here protecting this. I've got nozzles behind the filters protecting that. I've got nozzles in the ductwork to extinguish a fire when it gets up in that location. However, 15 years ago or so, maybe more, the UL 300 is a new test standard that these systems have to be designed to, because we used to cook with animal fat. Then we decided that's not really that healthy. We need to use vegetable oil. Okay, great. The problem is vegetable oil burns differently than animal fat. So the fire performs differently. And as a result, the extinguishing system needs to operate differently. That's the UL 300. Many of the old dry chemical systems, which was the common go-to system in cooking appliances, no longer function properly. or I'm not wrong. They do function, they will activate, they will discharge, but they don't extinguish the fire in all cases. So this new test standard was developed. It says all existing, so you get a plan in for a modification, addition, remodel, existing building. Code says all existing wet and dry chemical systems have to meet UL 300. First clue, if it's dry chemical, it doesn't meet UL 300. There are none that have passed the test yet. Water mist system could be used here also. Could be dry chemical, wet chemical, could be water mist, because water mist system is listed to UL 300. Standpipe systems. When do I need a standpipe in a building? The purpose of the standpipe is to get water for firefighting use into the building up on the upper floors or the lower floors. So a standpipe is required when the building has a floor more than 30 feet above or 30 feet below the lowest level of fire department vehicle access, or the building is 4 stories or more in height. Those stories are above grade. We're not counting basements. 4 stories above grade. Or it has 2 or more stories below the highest level of fire department vehicle access. It's a group A occupancy with an occupant load greater than 1,000. Covered in open malls, stages over 1,000 square feet. Underground buildings. And underground building just means that by definition that I have a floor level more than 30 feet below the highest level of fire department vehicle access. That is an underground building. I could have a high-rise building that is also an underground building. We'd call it a high-rise, but it also has to meet the underground building requirements in Chapter 4. Buildings with a heliport or helistop. Marinas and boat yards where I have access from fire department vehicles where they can park to the furthest point of the dock that exceeds 150 feet. When we look at number of stories, height does not apply to Group R or Group R 3.1. There's different classifications for standpipes based on what they're using. Class 1 is for fire department use, and it has 2.5-inch connection. Larger hose diameter, we're going to handle more water. Class 2, which basically is not required by the code any longer. It's for occupant use. It's for occupant use. The current concept is don't fight the fire. Get out of the building. Get out of the building. So that's why we don't find those going in. We have a class 3, which is a combination of 2.5 and 1.5 for occupant use, but you only find that one required in very few locations. Typically, it's 2.5-inch connections, fire department use only. In the design of the building, when a standpipe is required, I have to protect the standpipe riser and any laterals that go out to another outlet out on the floor somewhere, out on that story level. The protection has to be either within an exit stairway enclosure, or I provide fire resistance rated construction for that lateral. Or if the building's sprinklered, I don't have to do that. I provide sprinklers for the building. I don't have to protect those laterals. I still put the riser in the stairway because my 2.5-inch connection for the fire department use is also going to be in the stairway. Fire alarm detection systems. 2 sections in the code that deal with fire alarms. New buildings, Chapter 9, that's where we're at. There are some requirements in Chapter 11 for existing buildings. For group I2 or I2.1, group R1, R2 high-rise buildings, there are requirements to install a fire alarm system in those existing buildings. But the code does not mean you've got a really old system in your building, you need to replace it. As long as it can be maintained, it's good. What this means is you never installed a fire alarm system because at one time it wasn't required in that building. You need to install one. You need to install one. When it does not have a fire alarm, you need to install a fire alarm in that existing building. And this could be part of a TI remodel required. Group A, fire alarms now. Fire alarm. Occupant load is 300 or more. Or now I have an occupant load of 100 above or below the level of exit discharge. Or I have a group A occupancy used for education. Wait a minute, if it's education, isn't it group E? It's group E up to 12th grade. So what this is a group A classroom, occupant load in the classroom over 50 at a college, university facility. That's what that's intending to cover. And if I have multiple group A occupancies in a building, I consider the aggregate occupant load. I add the entire occupant load together like we did before, unless it's separated by table 707.3.10, the table in chapter 7 of the building code doesn't require a 4-hour firewall with no openings. For sprinklers, it does. This one, it just has to be separated. When I have an occupant load of 1,000 or more, that fire alarm system now takes a step up to become an emergency voice alarm communication system. A couple things change. It's a different notification that's sent out to the occupants. I get an alarm tone, and then I get voice directions on what to do. And that could be different for different floors, or even different for different wings of a floor, depending on what activated, what caused it. If I have an existing building, group A, and it does not have a voice fire alarm communication system, and it has more than 10,000 occupants, and it was built after July 1991, they have to add a public address system. Public address system is similar to emergency voice alarm communication system, but it's not the same. There's additional integrity and dependability requirements that go into the emergency voice alarm system. With the emergency voice alarm system, actually with both, the fire department can show up. They got their pre-recorded message that was sent out, but now the fire department shows up and grabs this handset, and they can give live messages to different floors of the building. Don't use the north stairway. Everyone go to the south stairway. They can give different messages. Group B, no requirement for sprinklers in a group B, but for fire alarm, yes. When the occupant load is 500 or more, fire alarm system required. Occupant load is 100 or more above or below the level of exit discharge. Group B, used for educational purposes. We're back to our college university building, and now my classrooms have less than 50 occupants. But it's still my educational facility and required to have a fire alarm system. There is an allowance that occurs in many, well, I guess all occupancies other than group H and I, that if the building is also sprinklered, my pull station, my manual fire alarm box, the manual activation portion, is not required except for one in an approved location. The reason this is allowed is if it's sprinklered, my sprinkler system is also tied into my fire alarm system. one of those integrated systems. When the water flow switch activates and water is flowing in the sprinkler system, the fire alarm system activates to provide notification. So I've taken that manual fire alarm system that was waiting for someone to hit the pull station and turned it into an automatic fire alarm system because it's connected to my sprinklers, but I still have to have one in an approved location. Group B, ambulatory care. If the building is sprinkled, I can eliminate all but one manual fire alarm box, but the fire alarm system is required throughout the fire area, regardless of occupants, number of occupants, regardless, required. Smoke detection system is also required throughout the fire area, and the egress path to the exterior, unless the building's sprinkled. Group C, camps. Detection is required. It says detection required where we're using sleeping. Basically, anywhere where people sleep, RIC occupancies, where they're sleeping, we have to have smoke detection. We have to have smoke detection. So at my group C, I have smoke detection in the sleeping areas, and then I have to have some type of fire, a camp fire alarm. And it's not a fire alarm as we think of a fire alarm system in a building. It could be any method of notifying people throughout the camp. I've seen the triangle in the bar. We're not calling you for dinner. This is our fire alarm. But then that's the only thing it's used for. Group E, automatic fire alarm system with voice, emergency voice alarm communication system required when I have an occupant load of 50 or more, or I have more than 2 classrooms or 2 or more classrooms, or I have more than one room used for daycare. Used for daycare. I always have to have at least one fire alarm box in an approved location. Typically at a group E, it's going to be at the administrative office or at an area where it's normally occupied. Smoke detectors in every classroom and in all plenum spaces used for handling or moving environmental air. Private schools, smoke detection required, unless it's entirely sprinkled. Group F, factory, fire alarm, manual fire alarm, 2 stories or more in height, or 500 or more occupants above or below the level of exit discharge. Group H, not all Group H require a fire alarm. You would think they do. Well, that's our highest hazard as far as fire is concerned. But only in Group H5, semiconductor manufacturing, or H2 or 3 that manufacture organic coatings. But there's other times, depending on what materials they're handling, that fire alarm or detection systems are required. For highly toxic gas, organic peroxides, oxidizers, I need smoke detection. I want early warning because the smoke detectors will typically activate before the sprinklers. All Group H are sprinkled. But I want early warning to let me know there's a fire because I got some really bad stuff in this building. I want early warning so we can go attack the fire and handle it and protect the facility. Group I, manual fire alarm required in all Group I. The manual fire alarm boxes are permitted to be at the attended locations only, so I don't have them basically open or available to the public here at the nursing stations, because I've got that nursing supervision in all areas of the building. I also need smoke detection in my sleeping rooms. Remember, we talked about sleeping areas. We've got smoke detection all places that we sleep, at the nursing station, and in corridors and waiting areas that are open to corridors. So throughout my corridor and the waiting area along that corridor, if it's open, does not have to have a fire resistance rating. There's no physical separation. Could be just a glass wall and a door. That would be enough separation. If I don't have that, I have to provide the smoke detection in those areas. Group I3, smoke detection again. I've got a manual system. I've got smoke detectors in the housing areas, in the sleeping areas, the day room, the common areas. We also have group I3 type 5, 6, 7, 8, 9, my temporary holding cells. Some require detection, some do not. You have to go back to chapter 4 in the building code to look at the criteria for those holding cells, temporary holding cells. Group I4 daycare, automatic fire alarm system. Group I4 daycare. Group L, fire alarm system required. So group L, mandatory sprinklers, mandatory fire alarm system. But we're designing this to handle and protect the group L. While my group L is more on the 10th floor or above the 10th floor in a building, I'm going to have a 2-hour smoke barrier to separate that floor level. And I've got fire alarm components on each side in each of those smoke compartments. Group M, mercantile. Mercantile, when I have an occupant load of 500 or more, or we're back to 100 or more above or below the level of exit discharge. Not required in covered or open malls. But so I've got a group M. Do I even make a group M that's over 500? We do it all the time with Home Depot, Lowe's, Target, Walmart, the whole gang of buildings over 500. Kohl's. The one difference with this fire alarm is instead of automatically activating notification devices throughout the building, they can have a signal go to a normally attended location. Normally attended means that there's someone there during working hours versus constantly attended. There's someone there 24 hours a day, every day. But I can have a signal go to a normally attended location if my system is now an emergency voice alarm communication system. Because now I'm going to get that signal. I'm at the normally attended location. I get the signal and I pick up my radio and say, hey, Billy, go check out I got a smoke detector activated in the hallway to the dressing room. Or I've got a pull station activated by the east exit door. Go check it out. I've got 3 minutes. In 3 minutes, the alarm goes off with emergency voice alarm communication, or I'm going to find out, oh, we do have a problem, and I'm going to give direction to the occupants in the store. We haven't dumped the store yet, but now I'm going to give them direction. Okay, everyone head to the north exits or the main exit. We need to leave the building. Group R1, hotel, motel, manual fire alarm system required in all of them. But then we have some exceptions. Building is no more than 2 stories in height, and the sleeping rooms are separated by 1 hour construction, which is required for all new facilities. And each sleeping unit has an exit directly to a public way, exit court, or yard. In other words, no interior corridors. I don't have to put the fire alarm system in at all if I comply with those criteria. Group R, I do have interior corridors. I had a manual fire alarm system. Now I'm going to add smoke detection in the corridor. The sleeping rooms have smoke detection regardless of interior corridors or not. They've got smoke detection. Now I'm adding smoke detection in an interior corridor in addition to, it's Group R, the building sprinklered. Group R2, manual fire alarm system required when the building is 3 or more stories above the lowest level of exit discharge. 3 or more stories above. I've got a single dwelling unit more than 1 story above the highest level of exit discharge. So the dwelling unit, I enter the dwelling unit on the 2nd floor. I've got more than 16 dwelling units or sleeping units. It's a congregate residence with more than 16 occupants. We're back to the same exception that we had for Group R1. Fire alarm system not required if separated by 1 hour construction. New construction required. And every unit has a direct exit to the exterior. R2, college university buildings. This is our dorms. This is our dorms. R2 occupancies operated by a college or university for student and staff housing. I always have to have a detection in the sleeping room. Got that. Now I'm going to add smoke detection in other locations. We continue to have fire fatalities in these buildings. So the smoke detection is intended to deal with an early warning to allow them to get out. Detection systems not required in buildings without interior corridors. If I don't have interior corridors, not applicable, not applicable. And in this building, typically in a hotel motel, the smoke alarm in my sleeping unit just sends a signal down to the front desk. The smoke detector in the corridor sets off the fire alarm. But now in this installation with my Group R2 college university building, any of the system activation shall set off the fire alarm system, even the smoke detector in my sleeping room. We want early notification to get those people out of the building. Manual automatic fire alarm system required where more than 6 non-ambulatory elderly clients in a Group R 2.1. Detection not required if everyone's on the 1st floor or if the building is sprinklered. Smoke alarms are required. Manual fire alarm boxes are required. It's sprinklered. I need to have 1. Group R 2.2, a very limited occupancy group classification. Fire alarm system is required. Automatic means smoke detection with at least 1 manual fire alarm box at the staff office. This is my return from custody facilities. Special amusement buildings. Special amusement buildings, which includes a haunted house. But anytime I have a building that is designed to confuse my egress path, it's not clearly identifiable. Special amusement building, smoke detection system required. Whether it is a permanent facility or a temporary facility just for Halloween. Smoke alarm smoke detection required. And when the smoke detection system activates, it takes several measures that are going to provide the occupants a better chance to get out. It's going to turn off all the noises or turn off the fog machine. It's going to illuminate my egress path, and exit signs are going to be very clear, very identifiable. It has a emergency voice alarm communication system. So I get directions, and it may be different directions depending on the size of this facility. I'm going to get directions on which way to go. And with that system, someone can give verbal commands that are disseminated out to the occupancy, directing people which way to go. Group high rise and group I2 greater than 75 feet. This are high rise. I mentioned that the high rise is determined when I measure from the floor level of fire department access. I've got another floor more than 75 feet above that. That is a high rise. Then we have a group I2 that's more than 75, with a floor more than 75 feet above the lowest level of fire department vehicle access. They are measured differently, but they both end up in the same category as receiving or having to comply with the high rise package, the high rise fire protection package, which includes smoke detection. And we're going to have smoke detection for the elevator control, elevator lobbies, mechanical rooms, machine rooms, air handling systems. Any air handling system over 2,000 CFM has to have duct detection provided for it to shut down and then notify that the fire has occurred. The emergency voice alarm communication system. I have to have fire department communications, emergency responder, radio recovery provided. All of those things are required in my high-rise package that applies to these facilities. Whenever I have an air handling system that has a capacity greater than 2,000 cubic feet per minute, I have to have duct detection in my HVAC ductwork to detect smoke. If I have a fire alarm system, that duct detector is connected to the fire alarm system. If I don't have a fire alarm system, I still have to provide the duct detector, but now it just sends a signal to a control panel. It just sends a signal to the control panel. It also shuts down the ventilation system, so I'm not continuing to pump smoke or push smoke throughout the building. It has to do that whether I have a fire alarm system or not. It shuts down the ventilation system. But now that I've got that duct detector in my ductwork, I have to have access for maintenance, inspection, testing, repair, which may include a access panel into the ductwork, or at least access up through the ceiling to get to the duct detector itself. We talked about sleeping areas, and so now here I'm in a R occupancy. I have my smoke alarms. A smoke alarm is different than a smoke detector. They both detect smoke, but a smoke alarm detects smoke and sounds an alarm. That's what you're going to find in your home. A smoke detector only detects smoke. It has to have a fire alarm panel that it sends a signal to. Then the fire alarm panel sends a signal out to the notification appliances, the lights, the buzzer, the whatever it may be. But they have different terms or different application. But I need smoke alarm at minimum anytime I have someone sleeping. New occupancies has to be a separate branch line for my smoke alarms, and my smoke alarm has to have battery backup. You can't buy one in California without it, at least not legally now. When they're interconnected, when I have more than one in my dwelling unit or my sleeping unit, they have to be interconnected so that all of them in my unit are notified. However, not the adjacent unit. Not the adjacent unit. Some new requirements for smoke alarms and smoke detectors around cooking appliances, because we get many nuisance alarms where the detector went off when it wasn't supposed to. There was no fire. It thought there was a fire because it got the smoke from the burning bacon. So and this is a issue for plan review and inspection. We have different types of detection. We have ionization detection and photoelectric. The ionization alarm is more susceptible to smoke. It reacts quicker to smoke than the photoelectric alarm. They both meet the requirements, but it does react quicker. So it is more susceptible to a nuisance alarm. So if it's an ionization alarm, it has to be 20 feet away from any cooking appliance. And that's 20 feet plan view. 20 feet plan view. Some of my hotel motel, my efficiency units, even R2 occupancies, 20 feet from the cooking appliance. May be tough to get. Option. It's an ionization smoke alarm with an alarm silencing function. In other words, it's going to have a button I can push on it to silence the alarm when it activates. It'll wait 3 minutes. If it's still detecting smoke, it'll go back into alarm. But it can be 10 feet away. Or photoelectric alarm. It can be 6 feet away. It is not as sensitive to that cooking type of smoke. So it can be closer. The whole intent is to eliminate or reduce the number of nuisance alarms when they activate and they're not needed because there's not a fire. The easy solution, hey, we'll just make them all photoelectric alarms. The problem, that's the most expensive one. So which one do the contractors want to install? I've got 400 units in this building. I need 400 alarms. Oh, wait, I've got one in the sleeping room too. I need 800 alarms. Oh, wait, I've got 2-bedroom units. Now I'm up to 2,000 alarms in this facility. I want the less expensive choice. Has to be here. You're doing plan review. You want them to either specify which type of alarm and then make sure the spacing requirements they can accommodate those, or have them put a note on the plans that says they're going to comply with the spacing requirements of section 907.2.10.8. Inspection side. How do I tell the difference? You got to pull it down and read the back. What type of alarm is it? What type of alarm is it? It's the only way to do it. Smoke alarms near bathrooms. Again, trying to reduce nuisance alarm. If I have a room that's going to create steam, I've got a tub, shower, sauna, whatever that is, the smoke alarm has to be at least 3 feet away from the door. 3 feet away from the door. Emergency alarms. Emergency alarms are intended, it's different than a fire alarm. Emergency alarm, only going to find it in a group H occupancy. It's either an H5 or I have highly toxic gas. Only going to find it in a group of H occupancy. And the purpose is, its message is We have a spill, we have a release, send the spill response team. That's the purpose of this emergency alarm. It's not we have a fire, everybody out. We have a spill or release. Do what you've practiced to do, and the response team needs to go. They're not leaving the building, they're going the other way to the fire. The company response team before the fire department ever shows up. So it's a different situation. It's a different type of alarm. Typically not red. The alarm, the manual release, it's going to look like alarm, but it's going to be blue, or it's going to be yellow, or it's going to have a different color. That's my emergency alarm. Carbon monoxide required in group carbon monoxide detection, I2, I4, and group R, and classrooms of group E, but only if there are fuel burning appliances in the room, or there's a forced air furnace with the fuel burning appliance that's supplying that room, or there's an attached private garage, as opposed to a enclosed public garage or parking garage, which we're already going to provide and take care of ventilation under Chapter 4. And with carbon monoxide, yes, it will kill you. It is invisible. You can't smell it. You can't see it. You can't taste it. But it is in the buildings. It's in the building you're in right now. It's okay, though. It's below a hazard level. It's below a hazard level. And we, as a society or civilization, we've created carbon monoxide since the caveman. Why is it now such a big deal? Because we've changed the way that we build buildings. We build them tighter, keep the conditioned air in and the unconditioned air out. Well, in the process of doing that, we're keeping whatever carbon monoxide was manufactured at the stove, at the cooking appliance, at the fireplace, in the heater. We're keeping that inside the building. We're not allowing it to ventilate and escape. The solution, ventilation. Just let it exhaust to the outside. That's what we do. So I could have carbon monoxide alarms, which are standalone devices with a detect and alarm, or carbon monoxide detector, in which case I need to have a control panel. And there are combination. In fact, the photo that you see here is a combination smoke alarm and carbon monoxide alarm. But I have to have at least one in the room. Section 916 deals with gas detection systems. Gas detection systems throughout the code. The code requires gas detection. It says go back to section 916 and install it under the requirements there. So this section 916 tells me how I design this gas detection system. And I detect it at 25% of the lower flammable limit, the LFL, the lower flammable limit, flammable gases, flammable liquids. This is our threshold. When I exceed that, the alarm activates. At that point, it is not flammable. It will not ignite. At 100% of the lower flammable limit, it will, or it is ignitable. This is for health hazard items. 50% of the immediately dangerous to life and health. That's what that means is at that level, at 50% of the IDLH, you have 15 minutes. You can survive in that atmosphere for 15 minutes. Time to go. Time to go. Get out of the building. But section 916 covers all of our detection systems. 917 is for mass notification, only applicable at a college university campus where I have multiple buildings. My mass notification system is basically my fire alarm system, not for the building, for the campus. So it includes all buildings. It includes all yards, spaces, outdoor areas in the complex. It covers the complex. Not always required. Not always required. The code says go to NFPA 72. Code says have someone do an evaluation under NFPA 72 that will determine and evaluate whether a mass notification system is necessary. If that evaluation justifies the system, then it needs to be installed. Smoke management, 909 and 910. Smoke management, there's two methods of handling smoke in the code. Either with a smoke control system, which is designed to protect the occupants, or with a smoke and heat removal system, which is designed to exhaust heat and smoke for the firefighting operation. Both of them provide for safety, enhanced for firefighting operation, reduce property damage, but the smoke control system, its main function is for life safety, to provide time for the occupants to get out of the building before there's too much smoke where they can't get out of the building. And there's several areas in the code where smoke control is required. High-rise, underground buildings, smoke-proof enclosures, and they're going to send you back to Chapter 9 to design it. These sections tell you, yep, it's required. Go back to Chapter 9 to design it. And there's a couple different methods of design. I'm going to construct smoke barriers to capture it and not allow it to move throughout the building. I'm going to pressurize different components of the building. I'm going to pressurize the stairway or the elevator shaft and not let it get into those areas. I'm going to exhaust it. In my atrium, I'm going to have exhaust fans that exhaust it to the outside. So there's different methods based on how you're going to provide it. Each one of these smoke control systems is specific for that building. So the volume is different for each building. The method of discharge or method of makeup air is different for each building. Each one is specifically engineered for the building. Needs to be considered as part of the engineering design. This is one of the reasons we get back to that requirement for NFPA 4, because each one's different. Go evaluate it. There is no set of criteria to comply with. Each one's different and specific for that building. Our smoke and heat removal, different application. I have smoke and heat removal in F1 or S1 occupancies over 50,000 square feet. I've also got smoke and heat removal required when I have high pile storage, but only when table 3206 in the fire code requires it. That's a fire code table. So it's not required in certain applications. But if I need to provide it, as a designer, I have two choices, either smoke and heat vents or mechanical smoke removal system. If I have, I'm going to use smoke and heat vents. If it's a sprinklered building, I can use that option. If it's non-sprinklered building, it's my only option. If I've got a floor above, it's not going to work. I can't ventilate through that floor above. I've got mechanical smoke removal. If it's a sprinklered building, it's an option. It's a non-sprinklered building, it's not allowed because it operates a little bit differently. Whereas the smoke and heat vents are going to open automatically, the smoke removal system is not. I've got a story above. Mechanical smoke removal is the way to go. Here's my smoke and heat vent. Located on the roof, operate automatically, mechanically, manually. I'll get up on the roof. Here's my manual release. Here's my manual release to open it up. If you're going out and you're doing inspection and testing needs, because they need to be tested when they're installed. If you're doing that, have someone else pull that lever, of course, and make sure they're not leaning over the top of this when that opens. These smoke and heat vents are designed to open with 6 feet of wet snow on top. So the weight of that 6 feet of wet snow, they're going to open. But they need to be tested, because when they're shipped, they have a safety installed. You're testing it to make sure they actually remove the safety, because they have to do that from underneath. They have to do that from underneath. Firefighting promotions. We've got the, I've got maybe 5 minutes. Hang with me. Fire Command Center in high-rise buildings and Group I2 with a floor level more than 75 feet above the lowest level of fire department vehicle access. In covered malls, if they have smoke control. In a building with smoke protected assembly seating. I have a fire command center. The fire command center, where the fire department is going to have, they're going to have my voice alarm communication system panel. I can access that from there. I can identify, I'm going to have a fire alarm panel, or at least an annunciator, to see what's going on there. I have various controls, and I know where the elevator is. I can tell which way the elevator is moving. All of those systems are going to be monitored and in some cases controlled from the fire command center. Has to be minimum 200 square feet, minimum dimension either way of 10 feet, and it has to have a separate ventilation system. Separate ventilation system for the fire command center. Emergency responder radio coverage required in all new buildings and can be required in existing buildings, but you're going to deal with it with the new buildings. But it's designed to allow for radio communication inside the building. The way that we build buildings now has provided a interference with radio communications. And so my radio responder radio coverage system is going to say, okay, you either need a repeater or you need some other antenna in the building, or you use some design to allow for communication between the personnel inside. And this is emergency responders specifically to cover fire, police, ambulance, whoever may be inside the building, so that they can communicate outside the building, either back to their dispatch center or even to the equipment right outside, because the buildings do interfere with the radio signal. But it's tested. You're going to receive a report. Yes, we completed the testing, but you want that report, you want that test done right prior to C of O. You don't want it early on, because not everything's in there. All of the components that are going to cause the interference aren't there yet. Right prior to C of O, they need to have it tested. You get a report saying, yes, it worked. And there we go. Chapter 9 in a very small nutshell.
Hi, Kevin. It's in the chat section.
Okay. I'm looking at that right now. It's from Rudolph. For a podium type building, where the first level is type 1, with type 3, 4-story above, R2 occupancy, can NFPA 13R be used? Okay, so the building is sprinklered. In the first level, we use NFPA 13. We have one sprinkler riser come in, and it's going up first level below the podium, or however many levels are below the podium, because now you can have multiple levels below the podium. You're not limited to one. NFPA 13, as I go through that horizontal assembly and now I go above, I've got the same riser, but now the question is, can I use NFPA 13R? I can, because I'm limited. I only have 4 stories. If The building height is no more than 60 feet from grade to the top of the R2, to the top of the roof height, to the top of the R2. If that is no more than 60 feet, then yes, I can use 13R. But keep in mind, when I do that, I lose some of the modifications that are only applicable to an NFPA 13 system in that R occupancy. Is smoke vent required for 2 and 3 story single family dwelling? No, smoke venting not required in any dwelling at all. Smoke venting is not required for dwellings at all. Only where we at? Smoke heat. There we go. Smoke venting. F1, S1, high power storage. That's my smoke venting. Do I need it for my smoke control systems? Not required. 2 or 3 stories, not a high rise. None of these other things would fit to my dwelling. So no, not required for any type of smoke removal. Any other questions?
Those are the only questions.
There are more. That's all I see. So with that, thank you for hanging with me. Sorry I went past my allotted time, but I'm going to turn it back to you, Maria.
Okay, thank you very much, Mr. Kevin Scott, for a very informative webinar. I would also like to thank each and every one of our participants